I want to welcome everybody, and certainly our virtual guests as well. Today is going to be a little of the old, some of the new, some old GHS, some new GHS, some old science, some new science. And if I had that there remote, I would actually change a slide. Life can be a venture sometimes. Okay. So who are we and why are we here? I'm very fortunate to have done a lot of things, and I see a lot of friends here today and at this conference that I've known for a lot of years. And one of the places I ended up landing was with R.J. Lee Group at the end. And R.J. Lee Group's kind of a phenomenal firm. It's basically like a university or Battelle Laboratories only on steroids because it's commercial. And so we can move at the speed of sound to get work done for people and do it competitively. In fact, I have a lot of clients, product stewardship clients, where we provide services gratis, not throughout, but we do a lot of work with them. So as a result, with special problems, we provide them with a lot of resources. I'm also very fortunate to have some very talented team members, including Dr. Stephen Monaco, who's a chemical engineer, and Dr. Alan Levine, who kind of covers a broad range of subjects for us. And this is our product stewardship leadership, in addition to the many, many employees that we have at R.J. Lee, who cover all the areas of microscopy and some really specialized equipment with XPS. Obviously, do a lot of X-ray diffraction, so fluorescence work, Fourier, IR, Raman, and a full suite of analytical chemistry. So we challenge and take on projects that no one else would touch because we have the unique capabilities and the professionals to be able to do that. We are also probably the largest electron microscopy lab in the world. We do a lot of work. In fact, right now we've had air sampling equipment on the International Space Station for years, doing ambient analysis of ambient particulate that's in the space station and it gets generated there. We do a lot of work with EPA and a lot of very specialized work for clients with our electron microscopy group. With that said, I want to introduce you to the world of chemical and SciComm for those of you who may actually not be involved with SciComm, but I'm assured that there are people at this conference who probably are. So if we're ready, let's take a hit.
SciComm is the strategic approach to international chemicals management.
SciComm brings together all stakeholders to make things happen.
SciComm reaches across all sectors to coordinate and share information.
Civil society, industry, and more than 170 countries participate in SciComm.
SciComm is creating a chemical-safe world.
2020.
2020.
2020.
2020.
2020. We're almost there. Let's get there together.
This is a UN initiative that was begun about 10 to 15 years ago. It is global. Whether we achieve the 2020 or not, I'm not sure. But I do know that this group is a part of this effort. Whether you realize it or not, everything that we do is global and how we impact the world. So with that said, let's jump back to some of the old GHS. Why did GHS evolve to begin with? Because we had this chaos on the left here. Typical caffeine all over the board, depending on which country you went to. Ultimately, this rating. And yet we still drink it every day. History slide, like we all need one. 92 in the Rio Summit, where all of this originated. 2003, the Purple Book. Oh, God love the Purple Book. And 3 to 5 year transition period for companies. And of course, then we've got the beautiful pictograms that we all live with every day. Advantages of GHS. There's got to be some good stuff in here, otherwise we wouldn't be doing this. The most relevant international source on chemical safety. Covers all chemicals, pure substances and mixtures. Harmonized criteria for classification of health, physical, and environmental hazards. And we critique this on a daily basis that it's not really harmonized. But those of us been in this for a while remember how when we had no harmonization and nothing at all. And yes, we can complain and we can moan and groan about borders and getting our products across and the paperwork that's required. But over the next 10 to 15 years, we're going to get much better at this. And we look at the effort like SciCam and how important what we do is. I forgot to tell you, I get a little social sometimes too. So, standardized labeling, safety data sheets, harmonized pictograms, single words, hazard statements for labels, responsibility of manufacturers and suppliers. HazCom was the responsibility of the employers. GHS made it the responsibility of the manufacturers and suppliers. Employers were required to have safety data sheets on every hazardous material that they had in their facility. It's the #1 violation under OSHA for the last 7 consecutive years is HazCom. And we redirected it. We made it the responsibility of manufacturers and suppliers. Big change in the US. Updating and maintenance by United Nations Subcommittee. Theoretically, it's a global effort, and we're all doing it together. It eases import and export restrictions, and I know the way we talk and the sessions that I've attended, we don't feel that that's necessarily the case. It'd be a lot easier if we didn't have restrictions and we could just import, export. However, then we run into another set of problems, and we don't need those either. And supposedly it minimizes trade burdens by limiting testing. One of the things that's really interesting about GHS is no testing required. We are not promoting testing. OSHA says the same thing. You don't need to test. I love that part. Expert judgment. We can just use expert judgment, and I always do the hexahexanafus, so I know what's in there. It doesn't quite work that way. We do a lot of testing, and everybody in this room, I'm sure, is familiar with all the testing that you do to find out all these fun things. The 3 hazard categories, 1 being the worst: acute toxicity, corrosion, irritation, carcinogenicity. Of course, we got the repeated and the single exposures. Aspiration is always a fun one, trying to figure that out. Then we've got our cutoff values and concentration limits. Very important numbers, and we all deal with them every day. This presentation is going to talk about how we actually measure the final product to determine whether or not that ingredient is at this concentration level with activity, biological relevance, toxicological relevance, and activity. So in 2013, when OSHA came out with HazCom, there was a little classification shock across the industry, because all of a sudden, employers had to be prepared to address new hazards for chemicals that they've been using in the workplace for many years. In fact, classification shock is a realization that chemicals are more hazardous than once thought, either because of the classifications or, in many cases, because the initial hazard was not properly evaluated, or poo-fooed, or blown off, or didn't care. It didn't matter. I always love the story about we've been doing this for 30 years this way. So what's the operational impact? What does this really mean to us as organizations and as companies? What has GHS done to us? Products with physical or health hazards increase development costs significantly. They require SDS documents. Hazardous product handling necessitates engineering controls and worker protective measures. And we're going to talk a little bit about what happens when we slap that hazard label on that product and put it on the dock. And then we put it in the truck and we send it to somebody else's dock. And that hazard label says you've got to have a respirator. You've got to be in PPE. You have to wear gloves. You have to have engineering controls. We do that every day. We put hazard labels on stuff that are not hazardous. I've been a hygienist and toxicologist almost all my career, and of course I'm not a young guy, so I've been around a while. And I think that we've done Prop 65 to ourselves worldwide. No one cares anymore. Everything's hazardous. And that's a big concern of mine, that we're not actually differentiating the real hazards from the stuff that isn't hazardous. So we're going to talk about that today. Spill response. If you have a spill now, you've got to deal with it. We're going to show you some things we did with materials to get them out of that. Regulatory requirements are expanded across all agencies. Not only is this an OSHA issue, but now you got a Clean Air Act issue, a Clean Water Act issue, a RCRA issue, and DOT. So the moment you put that hazard label on that product, it isn't just about HazCom and GHS. You've now impacted that product's life cycle on its environment on all those other agencies. And if you didn't have to have a permit before, now you may have to have a Clean Water Act permit. Tier 2. We've got to tell the community. If we've got enough of that material, we have to tell the community we're sitting on this material. We just opened up a Pandora's box for our organization. If we're a company with 300 or 400 employees that has never had to be involved in the local emergency planning committee, we are now part of LEPA. Oh, that's a tough one. Warning provision in the language of the destination country, and unfortunately some of these countries have 3 languages. Ouch. Those of you that write SDSs know the angst we go through with that one. I'm sorry, Mr. Client, you not only have to have it in this language, but we're going to have to pay for a couple more. And finally, the products have to be shipped as hazardous. Transportation cost, handling fees, time to destination. So let's look at the life cycle. It all comes down to the life cycle. Where does the hazard exist? Is it in the raw ingredients? That's what we classify according to. Physical hazards aren't classified according to raw ingredients. Physical hazards, Section 9, are classified according to the product as presented at the dock. But our health classifications are done on ingredients. Is the hazard in the anticipated use an extreme upset? And we're going to talk about this a little more because this is part of OSHA's regulatory body from '98 in the old HazCom. Or is it post-application, after everything's all said and done? Now all of a sudden the stuff becomes hazardous. It wasn't hazardous till we mixed it together and applied it, and now it continually emits or continually causes problems. Example, Johns Manville polyurethane foam. Obviously hazardous. This is part A. I mean, this is some pretty nasty stuff. Target organ toxicity, respiratory sensitization, Cat 1, that's anaphylactic shock potential. Workers wear bunny suits when they're spraying it, respirators. And then afterwards it's in our home. Not only in our home, but I'd like to know how this guy sprayed this stuff on this child without a respirator. My impression is that the child slipped into this costume and this was sprayed separately. But children on Halloween don't think about those kind of things. But whoever the parent was, I rest assured, knew that this stuff is nasty. So where's the hazard in this? It's in the raw ingredients. It's in the as presented at the dock. It's in the as used. But it is not, generally, we'd like it not to be, in post-application. We all use ingredients from our kitchen, and yet we all survive. Meat tenderizer. Tricalcium phosphate irritant, obviously. Papain. Respiratory sensitizer, category 1. And yet, here we are. Where's the hazard? We know the hazard's in the raw ingredients because it says so right here. Is it a hazard as presented at the dock? When you go to the grocery store, which is the dock, and you take it off the shelf, do you fear for your life? No. As used. When you're sprinkling this on meat and you guys are standing in the kitchen and you get that pepper in your nose and all of a sudden you sneeze, is it a problem as used? No. We know that. We don't know of anyone who has ever said meat tenderizer killed my spouse. And yet, this is the GHS. One of my favorites, as we go around the country making this presentation to AIHA local sections, and of course those local sections generally have some pretty talented and experienced people, including a lot of OSHA inspectors, a lot of NIOSH, experienced NIOSH people. And we start talking about sand and silica. And you're going to get more silica today than you probably want, but that's okay. It's a real important topic these days. And we start talking about play sand and playgrounds and the fact that there's no warning label or warning signs on playgrounds. And yet the sand that we put into the playgrounds has a hazard warning. It's the same sand. It hasn't changed. It's a multi-product SDS that Sac Creek puts out for this specific sand product. So they're covering all of their sand products. It's a Cat 1 carcinogen, repeated exposure, and a standard digital SDS. There's nothing wrong with the SDS document. Where's the hazard? Typical. Danger may cause cancer, causes damage to organs through prolonged or repeated exposure. Obtain instructions before use. Do not handle until all safety precautions have been read. Wear protective gloves, protective clothing, eye protection, face protection. Do not breathe dust, fume, gas, mist, vapors, or spray, and then let's put the kid in the sandbox. All on the same package. Where's the reality in all this? Have we lost our marbles? So one of the things that came out of a session this last week, was the opening session for IOHA, was a discussion on social justice. Having been a lifelong industrial hygienist, I'm very familiar and keen with the value proposition. We spent a lot of time working on the value proposition and going back to our companies and showing return on investment. If you'll buy me this piece of equipment, or you'll make this change in our process, or you'll do this, I can get you return on investment. It's good in 1 and 3 years, and now in some cases we could get plus return on investment. It may take a year, but we could actually make money on it. And then we had the collapse, the economic collapse. And I made the mistake of pushing the value proposition into my organization. The economic collapse came, they cut my department in half. Because I didn't sell social justice. Social justice is the difference between the two. Social justice is actually telling my management that this is about doing the right thing. This is about helping our workers, helping the local community, being a good citizen, corporate sustainability. I made that mistake. And I think that we need to get better at, as a professional society and group, is balancing both that return on investment and the social justice. This has got a problem. This isn't because of Lowe's. This is worldwide. So I'm going to challenge you guys today a little bit, my great product steward colleagues here. And by the way, you out there in the virtual, you're challenged as well. You're not getting away with just being out there on the other side of the screen. So let's look at these hazards and let's see what we can do to disprove these and change the rules and change the way we write these and get this right. Section 9. All this fun stuff. Has anybody ever seen an SDS where Section 9 was complete? Usually we get about 4, maybe 5 things in Section 9. And then we kind of wonder about them anyway because they look like somebody just scribbled them in by hand. Section 9 is about as incomplete as it gets. So if you were at SCHC this last week and the government in Canada did a survey of 170 SDSs on the market, And they came back with a compliance rate of 3%. And almost all the SDSs were deficient in this. I mean, probably every one of the 97 were deficient in this. But this is one of the big areas of deficiency. Misclassification, other things, but Section 9. So the question becomes, how important is Section 9? I don't know, I can tell you we rely on it. When we send the customer a survey form before we do any work for them, as far as working with them towards an SDS, we need product information. We need to know this information, or we can't prepare a decent SDS form because we don't have the details. So Section 9 is important. Oh, by the way, we do Section 9 work, just in case you didn't know. Safety data sheets. We're not a big safety data sheet producer. We rely on our digitizers. We love our digitizers. They do a good job. And it's much faster. We have a tendency, when we work with a client, we write a few by hand. We're a small SDS producer, very specialized because we have special language. And the language that we provide goes into Section 1, where we identify the substance or the mixture, and we try to get that right so that we don't fall into a loophole of having to classify something as hazardous when it shouldn't be. We also try to group products together to save our clients money. Section 2, and I'm going to show you some examples of Section 2 and how we exempt products in Section 2, yet we add a note. Section 3, obviously the most important part. This is where we list the hazardous ingredients. Well, what's really interesting is that we're very lucky in that 90% of the SDSs we produce are non-hazardous because we've done what we call hazard inversion. We've proven that that ingredient that is hazardous is no longer there. It doesn't exist. It's not bioavailable. It's not toxicologically relevant. Our toxicologist then signs off on it. Our chemical engineers sign off on it. We're done. We don't control the client's production. As a result, we don't sign the SDS. We don't put our name on it. We have no control. The next month, the product could be who knows. We have no control over client production. Those of you that work for corporations have that advantage. We do not as a consultant. And finally, Section 11. And I'll show you an example of that, where we have special toxicological data that we need to insert in order to demonstrate that we have met the expectations for exemption. So, neat products are easy. If we go into a neat product like toluene, we know what we've got, it's well defined, the toxicology is well developed, not a problem. Most of these really nasty hexyl ethyl methyl death, easy to classify. We know them well. It's the compounds and the mixtures that get to be a little challenging. That's where we've got to draw on our experience, draw on our skills. And one of the things that we do that's kind of fun, and I'm going to show you how we evaluate products later. We bring the product in. We've got the list of nasties. We've got the product composition, or what the client thinks it is. We then try to go in and tease out, just tease out, not separate. We're not looking to go in and rip that chemical back out of that compound because it's already bonded. We want it bonded because then it's not hazardous. But we want to make sure that when we say it's not bonded and it's not there, it's bonded and not there, that we're correct. So we carefully tease out. And this can get a little tricky, and there's lots of different methods, which is why we've got such talented people, to be able to tease out that little bit of that remaining nasty so we can find out if it's still there. But it gets more complicated. If anybody was at the Prop 65 session yesterday, they were talking about the chemical that they've changed a little bit. They changed it a tiny bit. They moved the ethyl chain from one end to the other, and all of a sudden it's not classified under Prop 65. Woo-hoo! Problem is, lab can't tell the difference. What we didn't talk about is, can the body tell the difference? Is it still just as toxic as it was now that we moved the ethyl chain from over here to over here? It's probably still toxic. Eesh. So we check activity. So we'll take that same product with that same nasty, and we'll see whether or not that chemical is active. Because it may be bonded and not free in the mixture or the compound, but it's still active. And if it's still toxicologically relevant, we can't pass the exemption on it. Okay? So not everybody wins. Most do, but not everybody. These definitions are really important when it comes down to GHS. Substance means chemical elements in our compounds, natural state, or obtained by production. Chemicals, any substance or mixture of substance. These all have very important definitions as we go through the exemptions. Mixture means a combination of or a solution composed of two or more substances in which they do not react. Alloy means a metallic material, homogeneous on a macroscopic scales, consisting of two or more elements, so combined it cannot be readily separated by mechanical means, are considered to be mixtures for the purpose of classification. So we're a member of the American Foundry Society, and we do a lot of work with the foundries. Some industrial hygiene, some GHS, and a lot of metal failure analysis for alloys and metals. And one of the things that came up recently over the last couple of years, recent when you look at my age, I guess, is the OSHA, State of Ohio OSHA, cited a foundry member for not putting a hazard label on a casting because the intended use of that casting was to be welded or ground to be mounted to another object. Okay, so you got a 25 or 50-pound casting that you set on the dock. Make sure you're wearing your respirator because it's going to release metals. You get it on the truck's got to be properly placarded because now we got a metals inhalation toxicity problem. You get it to the other dock of your customer, you get it on the dock, the guy's got to receive it in a respirator and a bunny suit. Finally, it goes into use. This one made everybody nervous in the foundry system. They didn't win the case. It stood up. So as a result, we now advise our clients that we are never, ever going to put a hazard warning on a casting because the biggest issue is whether you drop it on your foot. But what we will do is we'll add some special language. But alloys become important, and if you've ever dealt with articles and the article rules, I was just working with a customer on it actually this week, on whether something is an article. If it's formed to a specific shape for a specific purpose, it's exempt from GHS. So there's some ways around the casting issue. Not simple ways, but there's some ways around. So alloys become important. What are the rules? How do you do this? You can't just go and exempt products at will, can you? You bet you can. Especially if you've got expert judgment. Everybody in this room is probably an expert. You're either hygienists, you're toxicologists, you're experienced product stewards. You know GHS and REACH and ECHA database, how to get to it. And you know CLP, and you know these international regulations far better than I could ever imagine. And if you don't consider yourself an expert, you will soon if you stay in this profession, I can tell you that, because it doesn't take long to realize that there aren't that many people in it. There's probably only a couple thousand of us worldwide that actually have the wherewithal to stay with it. Because when you hit 7,000 pages of regulations and you go, man, this is kind of heavy, and you're right, it is kind of heavy. The criteria are semi-quantitative or qualitative, expert judgment required to interpret the data for classification purposes. Interpret. Nothing analytical about that. That's qualitative. The criteria for determining health hazard, test method neutral. They do not specify particular test methods, as long as they're scientifically validated. So yesterday, the folks from California are telling us that the state of California for Prop 65 only allows you to test by a California state certified laboratory. Fortunately, we are, but that's beside the point. That's not GHS, that's Prop 65, as long as the methods are scientifically validated. A chemical need not be classified or it be shown by conclusive experimental data from scientifically validated test results that it is not biologically available. What's the vector of exposure? Is it skin? Is it ingestion? Is it inhalation? Is it upper torso saliva and mucus? It's all about the vector of exposure. Epidemiological data and experience on the effects of chemicals on humans. This is a very interesting clause, by the way. Occupational data, data from accident databases. Who'd have ever thought you didn't have to do an epi study? We're all epidemiologists. Don't dare tell my epidemiologist. We have a professional epidemiologist as part of our team as well, and I'll never tell him that. However, what he can do is go into a company's records who've been producing that product for more than whatever number of years he feels comfortable with, and most of them they'll tell you it's 30, 40 years, and we've never had a health effect ever. Cool. How are your medical records? Oh man, we keep good medical records because we're union. All of our workers report every injury, and there's usually 5 a day because they don't like working too much. Have you ever had a lung effect? Any record of ever having lung problems? Nah, we don't get that one. It's always back injuries, leg sprains, elbow sprains, finger sprains, whatever it may be, broken bones, a couple of fatalities. But we've never had anybody report a lung ailment in 30 or 40 years of working with this material. Bingo! Epidemiological data and experience on the effects of chemicals shall be taken into account in the evaluation of human health hazards of a chemical. If you've got a product that you've been producing for 30 or 40 years that you know you have exposure to and no one has ever reported an injury and you've kept good medical records, you've got an exemption. It's that easy. Be smart. Social justice. We're not running away with the train here. We're not trying to create hazards where hazards don't exist. But if something isn't hazardous, let's get that label off of it so we can focus on the things that are and protect people and put our resources where they belong. I've spent most of my career managing EH&S programs for corporations. I'm now working in consulting, but most of my career has been managing large corporate EH&S programs. And we'll have multiple sites. And we'll have sites that cover up their injuries. They don't acknowledge lost time injuries. They don't acknowledge the serious injuries. They're in the comp records, and if you dig into the site's comp file, you'll find out that they had injuries they never reported up to corporate. But why is this important? It's important because if a site has injury problems, we as an organization can focus in that site, and we can give them the resources they need to correct their problems. So when we give bonuses to site managers and we give bonuses to the EH&S managers on those sites for no injuries, we're hurting ourselves. And this is an old debate within the EH&S community. Do we bonus no injuries or don't we? The same thing applies here. If we don't apply the focus to those chemicals that are hazardous and start screening this out so that we don't have everything hazardous, we're going to be nothing but a giant Prop 65. Conclusive data may demonstrate that the hazard of an ingredient will not be evident, does not pose a health risk when present above the cutoff. The mixture may be classified according to those data. That's pretty straightforward. Nothing to talk about much there. In other words, classification limits don't apply. It's not about classification limits. It's about bioavailability, toxicological relevance. When there's scientific evidence demonstrating a mechanism or mode of action not relevant to humans. Let me wrap this up with one comment. We do a lot of silica work. A lot of products contain silica, and of course we have the magic crystalline silica, all bad, everyone gonna die. And in some cases it's true. There's a lot of people that get silicosis, a lot of people that get cancer. There's some debate on whether you have to have silicosis first or not, doesn't matter. You also got lupus, you got some other autoimmune diseases, lots of things go on with silica. Yet we're all exposed to it every day. We now have a 0.1% threshold for crystalline silica. Is 0.1% even detectable? I'm going to tell you it's not. If you have 0.1% crystalline silica in your product and you try to do an exposure assessment or a release study on it, you will never see it. It will never exist. What are we doing? Did we do a little overkill here with the 0.1% for crystalline silica? The 0.1% catch-all is wonderful for carcinogens. It's a tremendous level. I love it. It captures those nastiest of the nastiest, and we get them tagged down and we get them under control so we're not exposing something that is really hazardous to people. But crystalline silica at 0.1% is nothing but ridiculous. That's all that achieves. So, you as experts can use your expert judgment to make the decision on whether you think that crystalline silica in your product at 0.5%, at 1%. When you start getting to 2%, you're going to start seeing it in your air samples. If it's biologically available and toxicologically relevant. We'll talk about that a little bit more. So, with that great introduction to crystalline silica, let's talk about it a little bit more. Crystalline material and amorphous material. Obviously, crystalline is the crystalline form, and the amorphous is the non-crystalline silicates, silicons, all kinds of silica containing mineral molecules that are not in a crystalline structure. So we're pretty good at crystallinity in physics and all this fancy X-rays and spectral examinations where you put something into the material and it comes back and tells you the crystalline structure. We'll talk about that in a minute. There's 3 polymorphs. And don't anybody fool you, there's a lot more than 3. This is kind of like the old asbestos problem. Ocean named 3 polymorphs, but there's actually 7. Most of them aren't that common, but the same problem with asbestos. Story for you. So we all know that Libby, Montana was the worst thing that ever happened to man. A lot of people died. But what did they die from? They died from asbestos. Was it regulated? No. The asbestos those people died from in Libby, Montana never was, never has been, and never will be regulated under U.S. environmental laws. They died from asbestos that you didn't know anything about. Not regulated. That's the problem with Libby. That's why it's such a big deal, because they didn't bother to tell the public it wasn't regulated. It was a different form of asbestos. Oops, we forgot to regulate that one. Nasty stuff called windchite and richterite. Unregulated. What do silica particles look like? They come in two forms. The really bad stuff and the stuff we don't really care about. The really bad stuff is freshly fractured. These are the guys working out there in construction, chopping it up, and you got watching the city of Plum, Pennsylvania here a couple of weeks ago, and I just saw the pictures yesterday. We were looking for them earlier. No respiratory protection, no bunny suits, no nothing out there saw cutting in front of our office, and the cloud of dust is coming up, and I'm thinking, man, these guys do this all day long. Probably not good. That's freshly fractured. Then you got these nice, round, aged sand particles, playgrounds, beaches, amorphous. Who regulates this stuff? Who decided this? Well, it starts with the International Agency for Research on Cancer, IARC. That's where it all began. And IARC says that particles with an aerodynamic diameter of less than 3 to 4 microns are respirable. Particles greater than 5 may not reach the alveolar region. Very good. Right on. That's good toxicology. That's correct. They also say that trace impurities affect the biological activity. What are the two things that just came out of that statement? Biologically available, pure and unbound. Key terms. National Toxicology Program just calls it RCS. Pretty clear. OSHA says that RCS means particles that are respirable. Very good. That was easy. Come on back here. By convention, particles less than 10 microns are considered to be the respirable fraction. This is what we use in industrial hygiene every day. We go out in the field, we set up a sampling pump and we're sucking air, called pump jockeys, and we put a cassette on the end of it, and then on the end of that cassette we put a cyclone that captures the respirable fraction so that we can actually measure the respirable fraction and get rid of all the junk. And we do that because the cyclone that OSHA has decided to assign to our world is this 10 millimeter nylon cyclone at 1.7 liters per minute. That changed with the new silica regulation. This is a little bit dated, but what did not change is this profile. And if you look at this profile, what OSHA's telling us is there is nothing above 8. So in OSHA's opinion, the toxicologically relevant portion is everything below 8 by convention. It's more or less a mechanical convention, not really a toxicological convention. OSHA does not tell us what causes cancer. Silica is one of the only OSHA-regulated carcinogenic materials that is not classified by OSHA. They have not classified it. They adopted IARC. And what does IARC say? IARC says less than 5 is toxicologically relevant. And they're right. IARC goes further. It says a mean aerodynamic diameter of 1.4 microns, range 0.3 to 4.0, was reported on alveolar duct, terminal bronchiolar surfaces. This comes out of the literature that IARC references. So in our opinion, our expert judgment as toxicologists, we've made the decision that we don't care about anything above 5. We're done. We don't care. It doesn't matter. It's toxicologically irrelevant. It's not biologically available. It's going to get hung up in the upper airways. You're going to spin it back out through the action of your lungs. Doesn't matter. And even more interesting, a study that was done in 2013 was a human health risk assessment for children versus adults. And which version was better or worse for children and adults. And in the case of adults, because we're not going to talk about children here, that's a whole different safety factor, and those of you that deal with safety factors know what I'm talking about. For typical activity levels and breathing habits, we estimated an aerodynamic diameter of around 3 micron in adults being the respirable fraction of the mid. So we're right in the heart of it. So when we do a regulatory brief for someone, for their legal regulatory affairs people, because they're challenging our direct contact, how can you do that? You can't say it's only less than 5. Watch me. We're going to put all this into a regulatory brief, and we're going to provide you with the ammunition you need to say, hey, you know what? All that other junk isn't important. It doesn't matter. It just falls off the truck on the way down the road. This is what's important. But how do we determine that true bioavailability? And I've given you some hints already on how we do it. There's lots of different ways and lots of tricks, and our guys are kind of like those mad scientists once in a while when I watch them go. But they figure it out. We start with dynamic light scattering. These are our accreditations across the country. Dynamic light scattering, we use a Horiba instrument for it. It gives this beautiful profile of particle size distribution. It's a little tricky, don't get me wrong. It's dependent on particle morphology, whether it's flat, whether it's long, whether it's short, whether it's round, whether it does all these things. Those things is dependent on the solution that you put a particle, the material into when you measure distribution. It can get a little bit complicated. People think that this machine is so easy to run. You just stick a little bit of fluid in it with some particles and you go and you get this beautiful spectra, and all of a sudden I can come in and I can make that spectra go upside down. It's not that simple. It's a little more complicated. However, it's a very easy method to run once you know what you're doing, and once we've run one type of material, we can rerun it and rerun it and rerun it for the same type of material. And there aren't many we haven't run on this. So we get this beautiful distribution. This is Minusil 5 pure silica standard. Mean diameter, just around 2 microns. And it's got this beautiful distribution, as Alan will tell me. Yellow play sand. Where does this stuff fall? Our kid's in it. Look at the size of that median particle. 135 microns. Woo! That's way up there. I guess we don't have to worry about that being respirable, huh? You won't even get that in. I mean, kids eat mud, right? My kids would eat it. So, what are you going to do? But what's interesting is that 6% is still less than 5. So there is a relevant fraction. What does that mean? We don't know. This is still undergoing some processing. It's actually a client material. So one of the keys that we use is an X-ray diffractometer. And everybody knows about X-ray because this is what's used for air samples for crystalline silica, for bulk samples for crystalline silica, the magic of the goniometer. Here's your sample, the X-rays come in and they go off at a specific angle, and that little tiny bit of angular difference makes all the difference in the world as to whether it's crystalline silica or not. This is a calibration spectra. Quartz, silver, and silver chloride. What's the silver in there for? The silver's in there because that's the membrane. That's what we filter the material onto, is a silver filter membrane. So that occurs way over here in Bunnyland. The quartz has these beautiful sharp peaks right here. Those blue lines are quartz peaks, absolutely sharp. We want to calibrate that instrument. Throw in some silver chloride, a little broader peaks, but exactly in the right spots. Perfect for calibration. Unfortunately, life is never so simple, especially when it comes to mineral products. I'll tell you what, we do a lot of mined mineral products. If it came out of the ground, we've measured it. Here's that quartz peak, and here's that mica peak. Is it mica or is it quartz? That requires a little finesse. Here's the cristobalite peak for cristobalite brand of silica, and here's the feldspar. The life is never quite so simple as we'd like it to be, but we sort through it and we figure it out. And then, of course, we've got to establish a calibration curve. If we're going to get down to 0.1% or less, we've got to have a calibration curve, which we've done. Beautiful curve. Okay. Calibration is 0.1%. course, we all know you got to be less than 0.1. Doesn't quite work that way. 0.1 fails. So we got to do some more work. The other problem is XRD cannot distinguish respirable from non-respirable. You take some material, you kind of grind it up a little bit, you get it on that puck that goes into the XRD instrument, shine that X-ray through it, comes off the other side. Problem is, we have no idea what the size of those particles are. We don't know. PSD data is giving us some information, but the X-ray can't tell us anything about relevance. It just looks at the bulk material. So let's shift gears and let's go to the SEM. Automated particle analysis. We started developing this for power plants for doing emissions from smokestacks. The SEM, in the system we use for our side is the IntelliSEM. The CCSEM is used on the community side for a little lower cost analysis. It's a different instrumentation. For our services, we actually go to a little higher level on something that's called an IntelliSEM. It's a little higher end instrument. We're a little fussier. So you get the particles, you measure the particles, you get a size on it, you sort them according to size, okay? And then you get the EDS, which is the chemical signature of that particle. And you get a great distribution of the particles by size, and I'll show you that in a minute. And again, we have to have a calibration curve so we know where we're at. And in this case, with greater than 90% silica containing particles, we've got a 0.05 detection limit. Limit of quantitation, actually. The CCSEM cannot distinguish between crystalline and non-crystalline. Ah, crap. So first we got the XRD, can't tell me if it's a particle or not a particle. We got the SEM, can't tell me if it's crystalline or non-crystalline. Man, what are we going to do? We got to get all this stuff combined. How are we supposed to get to the toxicologically relevant, biologically relevant portion less than 5 microns and get a weight percent? We need another tool. Oh, can't get there yet. Okay, now you guys, I think I've captured you as an audience, but we're going to find out because I made a promise. And that promise is to see whether or not we can all stand, because we're at 45 minutes, for a few seconds, and just kind of stretch ourselves a little bit so I don't lose you. Can everybody stand? Virtual audience, I need you guys to get away from your desk, get away from the donuts and the couches, and stand up for a second. And I'll tell you why we're doing this. We're doing this because the promise I made was that if I could get the audience to stand at my intermission point, I've got an 11-year-old at home who's the happiest kid you've ever seen. I don't know how you can not make 11-year-olds happy. They just giggle and laugh and sing all the time. So my 11-year-old and I do the happy dance once in a while. So I promised I would do the happy dance. Thank you. You guys can sit down again. What happened to my music guy? Did I lose you? We were supposed to have music too. It's a lot easier to dance to the music, you know? So I kept my promises. I'm trying to match the entertainment we got on the first day. That's a little tough. Those guys were really good. I got it. All right. So let's get to some real-world case studies. Perlite's pretty common material. We use it for soil amendment. It's actually used as a compounding filler. Pharmaceutical uses it a lot. In construction products, it gets into there quite a bit. And, joy to us, is greater than 0.1% crystalline silica. Call R.J. Lee Group. Let me fix that for you. How do we fix it? Let's take a look. So before hazard inversion, and this isn't one of our SDSs, this came in from the client at some point. Skin corrosion, irritation, we got rid of that. We worked with a lot of it. It may be the case, but it's not enough to be concerned about. Again, 30 years of experience with perlite, and you go in and you talk to the workers, you talk to the factory. No, we don't have anybody with skin irritation or corrosion. Serious eye damage, nah, these guys get it in their eyes once in a while, they go wash them out. And it is kind of annoying if you get enough of it on you, it's kind of grainy. So it's a little chalky, you know, it dries your skin out and that kind of stuff. But we're not going to give it hazard labels. It's not worthy of that, let me put it that way. The carcinogen, however, that's interesting, because now we got Cat 1A, man. If you get some perlite and you're going to use it in your garden, what do you got to do first? Get your respirator out of the garage. Don't forget to wash it. Wipe it out with alcohol wipes before you put it back on. Okay. XRD diffraction patterns. Perlite's some interesting stuff. Fluorite, corundum, quartz, feldspar. It's got a little of everything for everybody. Rietveld. When we get into mineral Mixtures. This is a true mixture. We've got to get a feel before we get into worrying about that 5-micron particle concentration of what the hell's in it. So we use a kind of a sophisticated least squares analysis routine where XRD runs that sample for hours. A little spendy, costs around $900 for this analysis. But we run it for hours, and when we get to the end of it, we can actually get quantitative numbers, and this is section 3 stuff for your SDSs. How much quartz is there, how much feldspar, how much corundum, how much amorphous silica, and then we've got this trace level that we can never get away from. Because naturally occurring mineral products always have other stuff. Usually some metals and things like that. Really, really bad metals. I'm joking. It's not the case. Just other junk. That's not really fully crystallized. It's a part of this and a part of that and a part of that and a part of that, and it's just kind of a mush. But in this case, less than 1% quartz. The rest of these are not hazardous. And the corundum, by the way, we think is introduced by the mining operation from the steel and the dragging and the buckets and all the things that go on with mining. Put it on the SEM. Beautiful spectra. This is what the particles look like. These look like freshly fractured particles. They probably are. They just mined it. It came out of the mine. They're probably fractured silica particles, crystalline silica particles. We don't know. We're going to have to dig a little deeper. All we know right now is that these particles contain aluminum, silica, and potassium. They're perlite. Those particles that are pure quartz, see any difference between those two? I can't tell the difference. Think your lungs can tell the difference? Yeah, your lungs can tell the difference. Kind of crazy, huh? Can't tell the difference visually, but biologically you can. Different activity levels on the surface. These other minerals make a huge difference on the activity of that silica particle and its ability to redox. It's an amazing thing. Perlite is not hazardous. Silica causes cancer, and yet the particles look exactly the same. Elemental signatures. Very important. We use this for exemption, and one of the things we'll talk about a little bit later is how we go through exempting. I'll talk about a little bit now. If we run particle size distribution on your material, on whatever it may be, and we find out that there is 0 particle content below 5, is it even possible for you to have 0.1% below 5? $300 and I go, bye-bye, see ya. You're done. It isn't there. It's not toxicologically relevant. You have nothing. You have nothing that can cause harm. It's not my problem. Okay? Same thing here. If we run you through SEM with EDS analysis, which gives us the chemical makeup of the product, we see the beautiful quartz with its silica and oxygen, feldspar, where we add aluminum and sodium and a little bit of potassium, and perlite. Again, a lot like feldspar, except the potassium is a little bit higher concentration. And the other ones are different, the aluminum and sodium, and then we got iron that comes into play a little bit. So the EDS signatures are different for all 3 of these. And then we count it, and we go through and we figure out for a diameter less than 1, silica-rich particulate, we've got 1.5, 2.5 microns, 12.2, 5 microns, 34.3, all the way up. So we have 100% across this whole thing, mass distribution by aerodynamic diameter. Okay. Only 1.9% of the material, however, on the SEM particle counting, and looking at all these particles, 10,000 particles by IntelliSem, 1,000 particles by CCSEM, which is one of the reasons we don't use it, plus the detector is much better on the instrument we use. So I'm going to stay with the 10,000 that we do in our group. Only 1.9% of that whole sea of particles was in here, and of that, only 34% was less than 5. So when you back calculate and you do all these wonderful back calculations, you find out that the total weight was 0.2% respirable silica rich. Very nice conservative approach to quantitation. If your product passes and its silica-rich particulate concentration is less than 0.1% of the less than 5 microns, it's bye-bye. We'll give you Section 3 language, Section 11 language, Section 1, Section 2 if you need it. We'll give you the language you need for your SDS. Go enjoy, group as many products together as you can, and you got in and out for a cost of under $750. And now you can remove the phone number out of savings of $6,000 a year if you're using Chemtrade. Okay. What if we're still above 0.1? Ouch. All right, it's going to cost you more money. First off, increase the peel. That's the first thing. But we'll get you around it. Raman analysis. Beautiful mineral matrices. Raman's perfect for this. Perlite, kaolinite, sand, gravel, bauxite, iron ore, vermiculite. We run these all the time, every day. The LabRam HR is our instrument of choice. It's fairly new. It's pretty sophisticated. It does automated particle counting. So we program it, walk away and let it run overnight. And when we come back, we've got 4,000 or 5,000 particles that have been analyzed. Specific to crystal. It can tell the difference between the crystalline structure. This is an optical image of what the Raman's looking at. The way it detects a particle as the stage moves along or the optics move, it sees the leading edge of the particle, and as that starts to ramp up, it detects it as a particle, and then from there starts its measurement. Contrast thresholds define the perimeter, so we can actually get a size. One of the problems, these are all 2D. 3D gets a little trickier. We can do that with the IntelliSem, and we oftentimes do go back and determine if the particles are flat or not, and exclude those that are not. That's a different story. Spectral identification of minerals: quartz, graphitic carbon, rutile crystallinity, anatase, type of crystallinity, carbonates, graphitic carbon with carbonates. So you get these beautiful differentiable spectra. You can tell the difference between these ingredients, between these mineral species. It's pretty accurate. It also does pretty well compared to the differential light scattering instrument. Raman and DLS do a pretty good job. Even though Raman's got that automated particle counting, that automated particle sizing, it's not too bad. So this is done with the Minusil silica. Okay. And we run a calibration curve on the old Raman, and we get, bingo, 0.01, which is where we want to be for Prop 65. Prop 65 and the zero exposure rule, this will make it. Now, if we can get this down another decimal place, which is what we're working on, we're going to try to convince OEHA that there's absolutely no reason to do any exposure monitoring when that material does not have any crystalline silica. If we're at 0.001, who cares? I don't know if we're going to get there, but we're going to keep trying. We are talking to them about it. So far, we haven't won. We're going to keep trying, see if we can win. And Raman determines the weight percent of pure and unbound. That's the part that counts. So now we got the particle size, we got the biological availability, the toxicological relevance, and we are into the pure and unbound. Very important. So Raman does this beautiful morpholite. Remember seeing this picture before? You saw it on the SEM. We are able to do intra-instrumental. We can move the same particles back and forth between two instruments. Gives you that beautiful quartz spectra, feldspar, and perlite. It's unambiguous, clear differentiation between the different crystalline and amorphous forms of the crystalline silicates. A Raman report, which is a little complicated because there's a lot of information here. For example, we find all these different ingredients in the mineral. That's lots of stuff. Not big quantities of it, but lots of stuff. This happens to be a 500 particle count study. We got quartz, we got cristobalite. Very little, but we've got some. And this is before back calculation, so these numbers are a little bit high. But the bottom line, we can then figure out all quartz, less than 10, less than 5 bound, less than 5 unbound. And we can do it for the cristobalite, and then we can do it for the total unbound. And then after we back calculate, this actually has a lower number. This has not been back calculated. So this is called instrumental analysis. It's going to cost you another $1,000 bucks. But my goal here is to get your product flipped. is your product really hazardous? XRD can't tell us. It can tell us how much crystalline silica you have, but it can't tell me what particle size. Particle size distribution gives me your particle size. If anything passes along the way, you can stop. But it doesn't tell me whether it's crystalline silica. SEM can give me particle size and it can give me distribution, but it can't tell me if it's crystalline. Raman can tell me crystallinity, but it's kind of spendy. But if I combine the two and I tell Raman to only look at these particles right here that I've already pre-qualified by SEM, I can get that Raman cost down from $2,000 to $1,000. And now I'm able to give you XRD, PSD, dynamic light scattering, SEM, and Raman. 90% of the time, over the last 2 years, the products are exempt. It's very rare to find a product that actually has enough respirable crystalline silica in it to warrant the label. So why do we worry about it so much? Because of the guys that are out there tearing down buildings and digging up highways and crushing rock, those guys, and cutting countertops. It's those guys that are out doing what the city of Plum was doing 2 weeks ago in front of my office. Those are the guys that are getting hurt. It's not the people that are buying your playground sand, which explains why playground sand isn't killing our kids. So by the time we got all said and done, and you probably recognize this 0.47 actually turns into this 0.05, you're cleared. No more hazard label. You do not have GHS level crystalline silica in your product. And we give you language for section 3, and I'll show you that shortly. This is the play sand. And we're currently working on this as a project. So I don't have more data than this, but we sieved it to 38 microns, and if you look, my lab did this work. At 39, we were at 100% sieved, so we could look at this lower fraction without interference from larger particles. We were concerned about larger particles. As a result, we also sonicated for 60 minutes to make sure we didn't have any agglomerated particles, so we had them cleanly separated. And we found out that this material has 28% less than 5. 28% of this fraction was less than 5 microns in size. So we're not to the end of it. We don't have the XRD data, we don't have the SEM data, and we don't have the Raman data, but right now we do have the PSD data. Okay, so that's where the natural place sand is fallen. Vermiculite products, another example. This is a material that was run through the dynamic light scattering instrument without pre-fractionation. That's why these particles are so large down here. And 0.5% was less than 5. By the time we were all said and done and we got through with the CCSEM, in order to determine how much silica rich, we found out that it was 0.08, and the product cleared. Fly ash. Famous fly ash, made more famous recently by the floods in North Carolina. As the dams breached next to the power plants and the fly ash started to go into the rivers, everybody got all excited, and we're going to talk about this for a couple of minutes. So with fly ash, and again you see that we did the entire material, we didn't fractionate in advance. That causes some interference when you have large particles, that's why we try not to do that. 25% was less than 5. Whoa, that's a huge fraction, less than 5. 25% of fly ash is less than 5. And if you know how fly ash is made, it's the combustion product on the big power plants that comes up out of coal. And as a result, it's really dusty, very, very dusty. And that shows it. We ran Rietveld on this baby because we wanted to know what was in it. So we got mullite, quartz, magnetite, calcite, and then lots of amorphous silica again. Actually, it could be something else too, just amorphous, non-crystalline. But we do have 8% quartz. We got some iron, some aluminum, and calcium carbonate. Okay. And the bottom line here is that it failed by SEM. At 25%, I'm not surprised. But if you look at how far down that dropped, from 25% to 0.5% of silica-rich particulate that could potentially be crystalline, it's a big deal. We are still waiting on this magic number. Once we have that, it'll probably drop this to about half. I don't know that this will clear. It'll be interesting to find out if it's actually crystalline silica or just silica-rich. But what's the big deal with fly ash? What's even more important? What's more important is that it's a big deal. Results in significant environmental problems. Everybody's going to die. We're all going to kill each other. If that was the case, do you really think we'd have these huge mounds and streams and ponds of fly ash sitting around? If it was really that bad, Probably not. So is it that bad or isn't it? Let's find out. We got an SDS to write. Let's get to the end of this. Well, one of the beautiful things about an SDS is we don't care about environmental. It doesn't matter in the U.S. Who cares? Because DuPont isn't going to do it. I ain't going to do it. And nobody else does either. Forget that, man. We get clients that need it for Europe, and then they want the OECD method, and I'm going, you are kidding me, right? It's a 28-day study. It's going to cost you like 10, 20 grand. You're dreaming. Why don't we just do a neutral leach like the state of Indiana does, and if it passes, it passes. If somebody wants you to do the OECD method, tell them, yeah, that's fine, but until then, we got neutral leach procedures for that. We also have procedures for determining bioavailability of the metals in fly ash. So we have adopted this study that was done for jewelry in children. And we've made the decision that we're not worried about there being a respirable fraction because there wasn't on the metal-containing compounds. We're only worried about the upper torso. We're worried about the ears, the eyes, the nose, the mouth, the ingestion, and the upper inhalation. So how do we measure that? We call it the upper torso. We measure it with this study. This is a leaching study where we take the fly ash material or anything else that we're doing. We've done lots of different materials. And we soak it in a biosolution made up of saliva. For those that don't know, you can now buy any body fluid you want. It's available online. It's kind of exciting. There may be some stuff you don't want to, but you can buy it. So we bought saliva. We call it MOPS mucin buffer. My biochemist put this together. So we got to set some limits. We can go ahead and leach it, but we got to figure out what's legal and what's not because there really aren't any limits. We kind of got Clean Air Act. We got Clean Water Act. We got TCLIP. We got the OSHA exposure limits. And we got the ACGIH. Well, the most restrictive of all these is ACGIH. So we know we inhale 10 cubic meters per day. And if we inhale 10 cubic meters over an entire lifetime, where are we at for ACGIH air? If we inhale every day for a lifetime, which is 40 working years of working life, we can take in 780 milligrams in a lifetime. Okay? So if we can take in 780 milligrams in a lifetime, and we know people drink 0.6 liters of water per day, that's your saliva rate. All these fancy calculations that my mad scientists keep shoving at me. And we find out that in this case, the limit is 0.17 milligrams per liter, and we ended up at 0.05 for the leached material. Bingo! Get it out of here. You're done. Move on. Fly ash is not the exposure hazard that's claimed, except we didn't get past crystalline silica yet. We're still working on that. But we did get past this part. Brown fused alumina. Once again, our great Rietveld work told us corundum 91% this time. Well, that obviously is not coming off of the machining equipment. The titanium aluminum oxide was 6%, the mullite was 3%, the rutile was less than 1%, the wustite, which is iron oxide, and then some unknowns at the trace level. Okay, well, let's see, what do we got here? This is brown fused alumina, and we'll talk about its physical properties a little bit in a minute. What's our hazard? Right there. Titanium, aluminum oxide, and TiO2. Known carcinogen in animals. Categorized 2A, I think. And so we do the respirable fraction. Ooh, that hurt, it failed. Okay, so we've got a respirable fraction above 0.1 and is a classified product. Let's do some research. Why are we not hearing about it being such a big danger? Well, the reason for that is that Dow and DuPont have decided that it's not classified based on available data. The classification criteria are not met. It has been classified by IARC as possible carcinogen to humans, 2B, through inhalation. This classification is based on inadequate evidence for carcinogenicity in humans, but sufficient evidence of carcinogenicity in animals, rats. We agree our senior toxicologist is PhD board certified, both US and Europe, plus we have 2 other toxicologists, one of whom is board certified. And they have decided that this is not classifiable. They agree with Dow and DuPont, and we've adopted their language into our safety data sheets for our clients. That's our stance. Now, we do advise our clients that you put yourself at risk when you do business with us, but we do carry E&O insurance, just in case. Okay? But that's our position. Oh, let's get into the fun stuff for Dr. Monaco. Chemicals and mixtures. Ooh, the good stuff. Get away from these physical hazards. We got to have some more exemptions. Can never get enough exemptions. GHS explicitly acknowledges the existence and use of all appropriate and relevant information concerning hazards or the likelihood of harmful effects. Peachy. The approach to classifying mixtures includes the application of expert judgment in a number of areas in order to ensure existing information can be used for as many mixtures as possible to provide protection for human health and the environment. And the point here is they don't want you to do testing. Well, you know what? I got to do testing or I can't get my clients' products exempted because expert judgment alone, my toxicologists are like, I don't think so. I'm going to have to see some data on that one. When it is clear that the mechanism or mode is not relevant to humans, a substance or mixture should not be classified. My favorite statement. Absolutely right. Let's stop classifying stuff that doesn't need to be classified. So one of our favorites is a grease product that got all spun up with the military and the Air Force. The actual Air Force helped develop this grease product. It's a very important grease for our armed forces in the gunneries, high temperature, those big planes that fly along with those big guns. You got to lubricate those guns. Those are big guns. If you've ever watched them fire, they will tear up anything and everything on the ground with those big planes. So the problem was that this material contained PTFE, Teflon. Teflon was the magic ingredient, along with a number of other proprietary ingredients, that made that grease slide so that those big weapons could stay firing under high temperature, thousands of degrees. Well, the old days, back in the 50s, someone decided that Teflon, which is a hydrofluoric polymeric chain, releases hydrofluoric acid. And we all know the frying pan issue with Teflon products, right? There is something that comes off of frying pans that cause cancer, and there was a big lawsuit, and we stopped using Teflon in our frying pans. Well, the military was concerned about the airmen getting exposed to hydrofluoric acid. So they discontinued use of the product. Well, for this company, discontinued use of their product done a lot of harm. So they asked us to get involved, and we did, and we went in and we measured all this. We went in and we checked for HF. Is there any HF going on here? What's going on? And we measured it with air samples, and we measured it with chemical analysis, and we measured it all over the place. There's the air sample results here. And everywhere we were, we found out that it was basically ND. This is pure PTFE powder. Okay, well, that's kind of a bummer. So we told the military, there's nothing there. We don't see anything. The military said, we don't believe you. Okay, peachy. Poor client. But we went and changed their safety data sheet in accordance with the results of high temperature product degradation testing using all these methods. Emission of decomposition products from proprietary ingredients, including PTFE, are insignificant. This analysis has substantiated that any trace level components which might be present, including HF, are inextricably bound, environmentally unavailable, and at de minimis concentrations. This is our language. How'd we do? We did pretty good. It's kind of legal beagle stuff, isn't it? You'd think we were like official. These results, combined with decades of application data, how you like that? Insert a little epidemiology into it too, huh? Yeah, baby. Demonstrating that these products to be harmless under both normal conditions of use and extreme upset scenarios have resulted in the exclusion of proprietary ingredients from further reporting and/or classification as either a health or environmental hazard. Bottom line is HF is not released, does not exist, will not exist. We have beat it to death. We spent $50,000 of the client's money to do every test God ever imagined, and we never found it. And then we fought for, about a month on the language and make sure we were word by word. We had every word that we needed in there. But we never found it. The military wouldn't believe us. Oh, you got to be wrong. We're the military. We're the Air Force. But then all of a sudden, somebody in the Air Force went, you know what, I got to check this out. Let me see here. So these guys out here at The 48th Fighter Wing decided to do a study. They went out and did this study. They were all below detection limits. There was no emissions. In their conclusion, the results indicate personal exposure to hydrofluoric acid while performing the inspection and maintenance of delivery system processes within standards. Based on a review of the data and air sampling results, exposure are not expected to exceed any regulatory action limits. Samples do not prove that HF is not a potential hazard when performing this process, only it wasn't present on those particular days. Thank you for qualifying that. The bottom line is it doesn't exist. And we are still fighting the Air Force to get this poor product back on the market because it's a better product for the guns. They went back to a legacy product from the 50s. And if you can imagine a legacy product from the 50s, it doesn't quite have the engineering that this new synthetics do. So it is what it is. But that's a case study for you. Oh boy. What have we done? Everything we can, and we still can't get below 0.1. Man. All right, client sending me now about $2,500 so far. We've run the PSD, we've run the XRD, we've run the SEM, we've run the Raman, and I still can't get that stupid material down below 0.1. But the client keeps telling me, man, I got to tell you, I know when no one's ever been injured here. This is ridiculous. We can't be sticking a hazard label on this. I got to put Prop 65 label. Sorry, you're going to get stuck with Prop 65 no matter what. I can't fix that part. But you don't have to put a hazard warning on it. You don't have to have a respirator. Just because you got a Prop 65 warning doesn't mean you got to wear a respirator. It just means you got to put a warning on it. Sorry, I love the Prop 65. Not a right-to-work rule for us, but I do love the stupidity of it all. Anyway, big client, lots of mineral products. You got to try something else. Okay, all right. Let's try something else. Let's use the Irish solution. So those of you who are industrial hygienists may be familiar with the 5-step paradigm. It's the one I adopted from Mark Hoover and Larry from Stanford, and some of the other great monarchs of our industrial hygiene community who mentored me, Larry Gibbs. And it is the anticipate, recognize, evaluate, control, and confirm. I've been using this for years, all the years. I'm past chair of the IHA Nanotechnology Working Group, and went out and visited lots of association meetings and lots of places over the years to make presentations. And this 5-step paradigm is the reality. Well, what I did is I changed it over to product stewardship. I got a little ambitious here a couple weeks ago internally, and I said, you know, I'll bet I can make this a product stewardship paradigm. Why not? So instead of anticipate, let's make it raw ingredients. What are the chemical properties, physical properties, and product formulation? Pretty good, kind of matches. Instead of recognize, let's make it as presented. What's the HAZCOM bioavailability of that presented product? What's the regulatory compliance issues associated with it? Anticipate. Okay, you guys got me. Evaluate, sorry. I don't always lose touch with that. Instead of evaluate, let's use as used, release testing, and Prop 65. Instead of control, end of life and industrial hygiene. Instead of confirm, patent infringement, class action, product liability. And then on the interior, we always have industrial forensics, corporate sustainability, and SEAMS. SEAMS is big data and the ability to manage all this. And those of you with SAP systems, I do not envy you because I've lived in those. And I now understand that they manage STSs through those, and I'm really doubly apologizing to you because you have to use the damn thing in order to create your STSs. But let's focus on release testing. We're nearing the end. We're into the Irish option. We know that's got to be rugged. Let's get in it. OSHA, in its generosity in 1998, made the biggest mistake it's ever made, again with language. Not really conflicting, just kind of, you got to do this, but that's okay, you can do this. Okay, which one is it? Well, we don't know. It depends on the case, and then we'll tell you after we give you the violation. So we fight lots of stupid cases. You said this over here, you said this over here. Here's a great example. The terminology exposed under normal conditions of use or in a foreseeable emergency, which is HAZCOM and kind of flows into GHS United Nations as well, excludes substances for which the hazardous chemical is inextricably bound or not readily available and therefore presents no potential for exposure. Thank you very much. Wouldn't that meet the castings? Right? I think the Ohio OSHA officer was on Lulu's. So we went in for this client who makes perlite. And we monitored this to death. Point of operation, nearest worker approach, general work areas. We didn't worry about personal samples. We threw a pump on the guys so they could get their OSHA compliance, but that's not what we were interested in. We were interested in release monitoring. We wanted to know what that equipment released while it was operating, not what was on the worker, because the worker is going to go all over. He went to the bathroom, went off to call his wife, went off on break, come, go all day long. We want to know what this machine was producing. Point of operation, nearest worker approach. That's what counts, not personal monitors. We don't believe in it. We don't use it unless we have to, because it's not good data. And then we've got to account for unforeseeable conditions. So 4 times during the course of the day, that poor guy, oh man, we buried him. We breached the system and perlite went everywhere. He's still in there. You just can't see him. And we did that 4 times throughout the course of the day to mock an emergency spill. Extreme upset condition. We felt we met the criteria. Haven't quite had another one like this one. That was pretty good. And we happened to catch a picture at the right time. What did we get? None detected. No crystalline silica detected. All day long. 4 extreme upsets. 0.2% by SEM. None detected. Crystalline silica is overclassified. It's heavily overclassified. So what I tell clients, if your product, certainly if it's less than 0.5, we're going to get you cleaned. Because if you've got a product that's less than 0.5 and you've got a history of never causing harm, and this is an example of 30 years of a plant that's never had a record of any, we're going to get you cleared. We're going to go in there, we're going to measure the flatness of the particle, we're going to make sure that it's actually a quartz particle, and we're going to get you cleared. There's no reason for us to have a bunch of materials on the market with hazard labels that the guy on the dock's got to be in a respirator if they're not hazardous, and silica is an example of that. You cannot detect it at those levels. There is no exposure. There may be some that's insignificant exposure. We're not worried about it from a toxicological perspective. Little different twist. This goes back to the casting problem with the brown fused alumina. So, as you'll recall in this one, we were doing TiO2. And the TiO2 failed classification limits. And we exempted it because we don't believe in TiO2. Well, this beloved material is also an abrasive. It's a blasting agent. So now, let's see. Should we be classifying blasting agents that we know are going to create this huge cloud of dust and they're going to have everybody covered in heavy metals? Silica and God only knows what else, right? As they blast and clean these agents and they clean that casting and they clean those walls, and we're going to have stuff flying everywhere. If you look at any STSs out there, you're going to find out they say yes. When that stuff arrives at your dock in that big bag, you got to have a respirator on because it says right here on the STS, respiratory protection required. We disagree. We think you need to have a respirator on when you're using it, but not when you receive it at the dock, because when you receive it at the dock, there's no respirable fraction. We've exempted the TiO2. So what we do in Section 2 is we add this clause. In its delivered state, the respirable particulate content of these products has been shown to be at de minimis levels and incapable of causing harm under normal or extreme upset handling conditions. Thus, these materials have been classified as non-hazardous for processing, shipping, and handling purposes. Applications which serve to crush, pulverize, grind, or fracture the material could, however, generate respirable particulate. As a result, and under these end-use conditions or application scenarios, the user is cautioned to implement exposure controls, worker protective personal measures, up to and until an exposure assessment is conducted, demonstrating that there is no human health risk and that occupational exposure levels are within regulatory limits for those respirable hazards generated as a result. Boy, you'd think attorneys were involved in writing this, wouldn't you? I'm going to tell you. So we exempt castings, where the biggest risk is going to hit your foot. We exempt abrasives, but we add these notes. If you're going to take this stuff and you're going to create a problem with it, we also add that same note to water. Here's your water. It's not a hazard, but if you're going to swim in it and never come back out, that's not going to work out well for you. Okay? We're trying to be smart about this. Even though we've created a conflict and we advise the clients of the conflict, the potential conflict that you have with the regulations right now, and we remind them of the fact that we know of one case where a citation occurred in Ohio, but that company went out of business and it wasn't because of the citation, so we never got to the end of that. We don't know of any others. And we are waiting because I guarantee you that the OSHA book of letters of interpretation is going to grow dramatically around GHS, and we're going to get interpretations for all this stuff. And we make this presentation. I think this is probably our 20th one that we made in the last year. And as a result, I've got lots of OSHA people in the room, and every time I remind them that you played in the sandbox, your children played in the sandbox, and now I saw you out in the playground the other day with your grandchild, and your child didn't have a respirator on. Now you tell me you want that silica sand labeled? Then you need to put the respirator on your child, your grandchild, when you're out there playing in the playground, because you and I both know that that's hazardous. And we both know it's not. So let's get this right. And it doesn't take long after you remind a regulator of that for them to go, crap, you're right. Okay. So release studies. We have a release facility that we use for Prop 65 and release testing in Pennsylvania that we do all these different things with. We'll do a lot of association work, like drywall products and concrete products and things like that, where we actually have associations, Foundry Society, different groups will come in because it's kind of spendy to do a release study. You got to set it up right. You got to have the right protocols. It takes money to write the protocol, get the protocols in place, and then we set our staff up. So we do lots of things with asbestos and with different silicates as well as metals. So we've got all that capability. And finally, last but not least, what if all else fails? Let's get an OECD compliant tox study in place. We have developed a tier-based tox testing program. It is 3 tiers. If you pass all 3 tiers, our toxicologist will give you the green light, and you can go ahead. Of course, your product's got to qualify to be able to do this, but in general, we get some products through here, and this is primarily the organics and whether it's bound or unbound and whether it's active or inactive, those kind of problems I was talking about earlier. So we check cell viability. This is the exterior of the cell. What's going on is your product going to tear apart the exterior of the cell, then we do the organelles on the inside of the cell, and then finally we do the DNA. So if it passes this test, it goes to the next test, which is a 3-part test. If it passes that, it goes to the final test, which is chromosome damage. Okay? And if you passed all 3, then you are a happy camper, and your product's on its way to the happy dance, right? Okay, summary. Level 1 inversion utilizes XRCM to accurately determine the weight % of free unbound biologically available. Should there be less than the cutoff, the mixture is reclassified. Level 2, internationally recognized release monitoring techniques to quantify the potential exposure if we're unable to get you through scientifically. Level 3, internationally recognized in vivo, in vitro testing, because this gets the most expensive. That's around $10,000 to $15,000 per material, depending on what we've got to do. So after we're all done and we've achieved hazard inversion, not only the happy dance, but classified components, not classified under OSHA HAZCOM. A little bit of language. We normally go with crystalline silica. If it's in the product, even though it may be less than 0.1 respirable, we will add this non-respirable so that we don't disguise it. We're not telling people it isn't there. We just tell them non-respirable. We'll add a paragraph under hazard components that says these products make and trace levels of naturally occurring respirable crystalline silica, in this case hydrogen castrobilite, at concentration levels below the HAZCOM 2012 GHS Revision 3 hazard classification limits for reporting. Internationally recognized and validated test methods, remember where that came from? That was one of the exemptions, that verbiage, have shown that these component ingredients are present but are not at reportable or biologically significant levels, thus in the current and anticipated future physical state, they are believed to be incapable of causing harm under normal conditions of use or as a result of extreme upset. Don't forget that part, that's really important. And then finally, we'll tell you how we achieved that goal per XRC analysis, which combines the analytical capabilities of X-ray diffraction, computer-controlled scanning electron microscopy, energy dispersive spectroscopy, and Raman spectroscopy to conduct particle-by-particle inter-instrumental relocation of physical, chemical, mineralogical analysis. Gobbledygook. Okay. So this is the Section 3 language. So when you process materials, and whether you do that with us or you do that with somebody else, this is good examples of how we handle Section 3, and we've removed the hazard, but we're telling the people out there that receive our safety data sheets that, hey, Be smart. Here's what we did. It contains some crystalline silica. Here's the percentage. It's non-respirable. Here's how we found that out. Okay. Project flow. Oh, I'm going to blaze through this. So when a project comes into our team, we review bi-weekly. We meet bi-weekly on new incoming materials. We do not provide quotes. We don't provide chain of custodies until we've actually physically seen the material and seen the project. We have a team of about 5 to 10 people that sit down every 2 weeks, and we evaluate projects. We evaluate materials, and then we tell the client, can we do it or can't we do it? Sometimes I already know the answer to that, so I can work with the client in advance, but we get some really complex materials in to be hazard inverted, and so our team's got to sit down with them. Our toxicologists are there, our chemists, our engineers, our industrial hygienists, everybody's together, and we meet every 2 weeks for a couple of hours and go through materials. And then we do that every 2 weeks, and we look at the outcomes, and we decide whether or not we need to go back into further analysis of what we need to do. So it's a sequential process for our clients, and we don't do analysis that's not necessary. We start with the simplest, and this takes time. This is not a 10-day turnaround. It's 2 weeks before you even get a meeting on your product. So this usually takes about 2-3 months, because we are not going to speed through this. Those T's have to be crossed, those I's have to be dotted, and our attorneys are not going to allow us to just slap stuff together, okay? Nor should yours. So when we go through this, it's a very meticulous process. These are the go, no-go gauges that we use as the material goes through the system. If it passes the first step, we terminate. Pass the second step, we terminate. So we don't spend your money unless we need to. And finally, if we'd had a little more time, I was going to have you tell me what analysis we should do on that natural play sand, because you just went through all this. Particle size distribution. If there's nothing below 0.5 or 5 microns, you're done. Pretty simple test. Doesn't take a lot to do it. No sophistication. Very highly accurate. It's a good test to run because there's no guessing games. Everybody knows what particle size distribution means. It's a few $100, but it's a really easy test to run. Second test, XRD. Does it even contain crystalline silica? If it failed the PSD, now XRD, that's about $300–400. Does it even contain it? And if so, how much? You generally already know that when you submit the materials. Third is SEM. Okay, SEM can get a little spendy depending on what we're doing, about $500 or $600. Okay, we get you quantified down to silica rich, and then if we got to shift over to Raman, now we're hitting the $1,000 mark. Okay, because the Raman's a very sophisticated instrument to run, plus it's absolute. It does crystalline, so there's more time involved on each analysis. Okay, it's all about machine time. And then ultimately we can go intra-instrumental, where we can go between the two machines. Okay. And I'm going to skip the HAZCOM song because it's 4 minutes and we have reached our time limit and I'm losing my virtual audience. So with that, I thank you guys. You've been great. Thanks for joining me in my midpoint today. Is the virtual still on? Okay. So if anybody has a question, please use the microphone. We'll be glad to answer them either from me or my team. You guys have to have unique products out there. It's like, how do I do this one?
But we sell barite, and obviously there are some impurities of crystalline silica in there. Mm-hmm. How do you get by the letter of interpretation in 2015 from the OSHA where they were asked that question, is it a respirable fraction or is it a total? And they clearly said it's total and not respirable.
We have done numerous regulatory briefs. There isn't a large client that we've done this kind of work for that hasn't had someone challenge us about that. Usually it's from internal, because they've been doing it this way forever and there's a letter of interpretation on it. So what happens is we use OSHA's own rules against them, and in fact, if you dig deeper, you'll find out that OSHA discusses this discrepancy. I can't remember what it is right offhand right now, but there are some discussions that OSHA has had publicly on this discrepancy that indicates that they too recognize that HAZCOM is the superior regulation. And that's what happened, is that their new HAZCOM regulations superseded those arguments. And so they've got to honor the 0.1% respirable fraction biologically available and let us use expert judgment. Now, that doesn't mean they can't cite you. And I always tell my clients that. I can't stop them from citing you, but I am prepared and fully prepared to defend you. It's like Prop 65, only kind of with an attitude. because now it's OSHA, which means that they can take it a little further, right? I can't do much about that, but ridiculous is ridiculous. And again, it's the sandbox argument. The moment we go at them with that, it's like, you're right. I took my grandkid to the playgrounds last week. I watched them play, and they were throwing up dust and eating mud. How do you get around that? I mean, it's ridiculous, right? We're going to put labels, warning. I feel so bad for Lowe's and Home Depot because we were at a conference earlier this year, and Lowe's was in the audience. And it's like, I'm sorry. I didn't mean to do that to you. It's like, what are you going to do? I mean, they're running gun shy. And they still got to put Prop 65 on because as long as it contains that crystalline silica, it doesn't matter if it's respirable or not. And OEHA isn't giving us a break on that right now because the laws are written for exposure only. So we got to and they won't let us use non-exposure data. That's the problem. So we've got some debate. So someone's going to end up paying for those exposure studies at some point. There's been 2 done for silica so far, the cat litter and the paint. There's been 2 safe use determinations. And they were both very expensive. Very expensive, unfortunately. This is a real venture, this world. If you guys, Wednesday we did the IOHA and made a presentation. And one of my big concerns here is we have this conflict in the rules. And this conflict is terrible. In that we've got expert judgment, all these beautiful exemptions, expert judgment, 0.1%, measure it, get rid of it, reverse it. And then at the same time, we've got this OSHA thing going on and this Prop 65, and it's like, we really have a really big conflict here. I don't know how this is going to get resolved. I don't know. I think it's going to take some litigation somewhere. But I'm not going to accept it. I'm just not. I mean, it's ridiculous. It's not hurting anybody. We put our grandkids in it. It's got to stop. We can't do that. I mean, the double standard kills me. It just kills me, this double standard. And I'm also concerned, the SciComm, one of the reason I shared the SciComm, I think what we're trying to do as a globe is really important because we've had a lot of people die from chemicals. But we're not focused on the really bad ones because everything's hazardous now. And so the really bad ones are like getting away with it. We've watered down the hazard of the bad ones because we've raised the hazard of all the stuff that isn't bad. And I'm going to keep advocating as much as I can for it, for what it's worth. If they're going to give me the stage, they're going to hear the same argument all the time. Get it right. Let's stop doing this. I've been in this too long. I've been OC Health all my life since the 70s. And it's really sad to watch. What do you think, Adrian? Thank you for joining me for the happy dance today. That was cool. Thank you, guys. Thank you, virtual audience. Appreciate you. There's some 5-page. I gave you guys the covers on the tables. There are some full 5-page white papers here in my business cards. If we can help you, let any one of my team members know. We'd be glad to work with you.